Okay, with part 4 here, we're going to talk about a few of the things that's going to be on the test, and you'll see them show up on the alignment machine, but we don't necessarily have an adjustment for them. It's kind of a part of a bigger thing, but you'll see kingpin inclination. So kingpin inclination is, even though we want this tire to stand straight up and down, right, and not be leaned in or out at the top, okay, the kingpin itself is not standing straight up and down, it's angled. Okay. The reason we want this kingpin angled, now the kingpin's angled and the steering knuckle is offset so that when the tire is steered forward, it's standing straight up and down. Okay. But there's a angle, a tilt on the kingpin itself, so it's not standing straight up and down. The tire is, because it's a wider distance at the top than it is at the bottom, because the kingpin's angled. You're thinking, now why would they do that? And we already talked about how that we have a caster where that the kingpin is tilted from the side, right, a little bit back. Okay, so these two go together to give us what's called a steering axis inclination, SAI. So steering axis inclination is those two that we just talked about working together, because when you're driving straight down the road, everything, you know, the tires are pointed straight down the road and everything's great. When you go to turn, though, the outside tire has to take a different radius to negotiate that turn than the inside one. So the inside tire has to turn sharper than the outside tire to go around that corner. So we want it to all be straight when we return to center. We also want to not have to fight the steering wheel to straighten the vehicle out. Have you ever noticed when you drive a car, when you turn a corner, you just kind of let the steering wheel ease up a little bit on it and the car actually straightens itself out, or the truck straightens itself out once you go around the corner and want to straighten back up? That's because of that steering axis inclination. So you'll see it show up on the machine. It'll ask you about it on the test and stuff, but the adjustment for it is no parts being bent, meaning that the caster is all set right. That's all predetermined as far as the kingpin inclination, the angle that direction. And then if your caster's set right, those measurements will be in. There's not an actual measurement on the machine to tell you that. It may give you a specification for it, but as long as camber's right, the axle's not bent, and caster is right, then you will have your steering axis inclination set properly. The last little one I want to talk about is scrub radius. You're going to see that on the test as well. Scrub radius is, if you looked at the kingpin and you continued on down at that angle, where that kingpin would touch the road, if you're viewing it like from the front, they kind of want the center of the tread touching the road at that point. So once again, as long as camber's right, that's right. But scrub radius is that, just that. They want where the kingpin would contact the road, if it continued on the angle that it's on, like an imaginary line straight down to the road, they want it to hit the road where the center of this wheel will hit the road. And that affects braking and some other things. Once again, that's not adjustable. If you put a different wheel on here, a deeper dish wheel, and moved this tire out or inside, so you see people putting those extenders and stuff on their vehicles now to extend their wheels out on pickups and cars and stuff, that messes that up, and it can affect your braking performance and all kinds of problems. It's not a good deal to be doing that. I know a ton of people do. It's a popularity thing. The last little thing I want to talk about, we talked about camber earlier being a tire wear component, right? Because if I put a negative camber, is what we normally see, in the front of the tires leaned in. So a lot of the little cars you look at, especially cheap cars and stuff, as they start aging and all the front end parts start sagging and wearing out, the tire starts leaning in at the top. When it does that, it'll chew the inside of the tire completely off, and you'll have steel belts showing there and good tread on the outside. So a lot of times we look at a car and say, oh yeah, the tire's good, and then we happen to get in it for an oil change and there's metal hanging out here on the inside, but the tread out here looks good. That's going to be a camber problem. Okay, negative camber, where's the inside. Positive camber is like pigeon-toed, where it's out at the top. It's going to wear the outside of the tread. It won't be feather-edged, but it'll be uneven wear across the tire that way, and that's what that will be as far as camber. Now, there's people that say, well, camber won't give you a drivability problem, it's just a tire wear problem. And caster won't give you a tire wear problem, it's just a drivability problem. Camber can give you a drivability if you have positive on one side and negative on the other, where that both tires are leaned. Then the vehicle is going to try to roll to that side. So it's kind of like being on a hill, right? If both your tires are leaned this way, it tries to roll off the hill. So camber can give you a pull, but one has to be positive, one has to be the negative, the same amount, where the wheels are kind of tilted and it will pull to that direction. But normally, if just one side's out, it's not going to give you any kind of drivability problem. It's just going to wear tires. Caster wears tires, but only on corners. So we talked about that steering axis inclination, where we get different angles. Basically, we get positive, extra positive caster on both front wheels when we turn with that steering axis inclination. So caster can wear tires, but it's going to wear them out when you turn a corner. So if you get a vehicle that the tires squeal when you turn a corner, you can hear the tires like making a little squeaking, squealing sound, like they're sliding. A lot of times the caster's out on one of those, so they're not at the right angle, and it will wear the tires out, but only when you're turning, not when you're driving straight ahead. So that gets us on test sometimes, because it will say which of these is not a tire wear factor, where they're really talking about straight down the road, not when you're turning. So don't overthink it and say, well, you know, caster can wear tires, but only when you're turning. They're kind of implying straight down the road. Now, if it said it could wear them, you know, on a turn, then yes, caster being out can be a problem there. Okay. We also, and it's in the book, I should have looked the numbers up. We have a crown on the road, right? So the road's not flat. It's actually higher in the middle, and the lanes kind of roll off on either side for water drainage, so that water runs off of the road. The truck actually has the camber moved a little bit on the driver's side wheel normally, to help keep it from trying to roll off of that corner. So if you're on a hill and you try to roll forward, if you're like pushed a little wagon or something on a hill, it kind of tries to roll off the side of the hill because of the angle of the hill. So since our road has crown in it and is sloped just a little bit, we will adjust camber on one wheel just a little bit to help keep the truck running straight down the road and not wanting it to, or car to roll off of that crown.